Hey everyone! Today we are doing something fun at JLCCNC. One part, 4 materials: aluminum, steel, copper, and PMMA, same geometry. Totally different stories. These are the class representatives: 6061 aluminum, 45 steel, T2 copper, and PMMA acrylic. No single grade covers a whole category, but as a start, these 4 are perfect. To ensure a rigorous comparison, we're using 4 materials with identical volumes and evaluating their weight, hardness, appearance, electrical and thermal conductivity, and cost. Let's begin. First up, weight. I let the materials speak first. This one, you can already tell, super light, almost feels like nothing. Now this one, same size, completely different story. Now let's get precise. PMMA, the lightest. 6061 aluminum, still manageable. 45 steel, now we feel the mass. And T2 copper, the heaviest of the 4 by far. The reason comes down to density. For PMMA is 1.18 grams per cubic centimeter. 6061 aluminum, 2.7. 45 steel, 7.85. And T2 copper, 8.9. Copper is 7.5 times heavier than plastic. The weight ranking, copper is heavier than steel, aluminum, and then comes PMMA. Need something light? Aluminum or PMMA. Need some mass? Steel or copper. Next, we'll examine hardness as a key material property and compare the differences between PMMA, T2 copper, 6061 aluminum, and 45 steel. PMMA is prone to surface scratches. It is suitable for visual prototypes, but not ideal for load-bearing parts. T2 copper is relatively soft and can bend easily, but it offers excellent ductility and machinability. 6061 aluminum shows only slight surface marks on most cases, while maintaining overall structural stability. And if higher strength is required, 7075 aluminum, often referred to as aerospace-grade aluminum, is also available on JLCCNC, offering significantly higher strength than 6061. In contrast, 45 steel shows very little surface markings after machining, with very high hardness and rigidity. In terms of hardness ranking, 45 steel leads, followed by 6061 aluminum, then T2 copper, and finally PMMA. In general, higher hardness improves wear resistance and surface durability, but it also tends to come with higher machining difficulty. Let's talk aesthetics, because appearance matters too when choosing materials. First, 6061 aluminum, silver gray, with a uniform metallic finish and distinctive CNC machining marks. If needed, anodizing is available at JLCCNC, while also improving hardness and corrosion resistance. Next, 45 steel. It appears dark gray with sharp edges, giving that strong industrial look. However, it does require surface treatment to prevent rust. 6 PMMA is highly transparent with excellent light transmission, but the surface scratches easily. And finally, T2 copper. It has a red-gold tone, very visually striking, but oxidizes quickly over time. That's why copper parts usually need sealing or coating to preserve the finish. Now, since we're talking about copper, we can't skip its superpower. Thermal and electrical conductivity dominates all 4 materials. That's why CPUs and electrical cores use copper. PMMA is the perfect insulator. Thermal conductivity ranking, copper first, then aluminum, then steel, PMMA, same for thermal and electrical. Now let's move on and compare these materials based on their cost and application requirements. For applications where hardness, strength, and wear resistance are non-critical, PMMA is often sufficient. It meets basic functional requirements and is generally a more cost-efficient option. When higher levels of hardness, structural strength, or durability are needed, aluminum becomes a more balanced choice. It offers significantly improved mechanical performance compared to plastics. At the same time, it maintains a more controlled overall cost compared to copper and steel, making it a good balance between performance and material cost. For applications that require high load-bearing capacity, wear resistance, heat resistance, or long-term stability, steel and copper are more suitable. They provide more comprehensive performance capability, but they also come with higher material in general. So in practice, material selection is not about choosing the most expensive or the cheapest option. It's about matching the material to the actual application requirements. So, what's the takeaway from all of this? Material selection is engineering. There is no universally best material, only the right fit. Lightweight, aluminum or PPMA. Strength, steel. Or conductivity, copper. Whatever your requirements, JLCCNC has the material and precision to match. Upload your design and get a quote in seconds. Follow JLCCNC for more CNC insights.